Indiana University East Chemistry C105 and Physics P 110, 120, 125. Properties of waves. So waves are really how energy is transmitted through a regular pattern of fluctuations in the magnitude of whatever's carrying the wave. For example, in this water wave here, a regular pattern of peaks and troughs, and this is what we call a wave. And to characterize a wave, we have three distinct properties we look at. We have amplitude, which is, okay, note carefully, the displacement of the maximum, okay? So this is the max displacement from the midpoint, okay? The wavelength is the separation in length so that's in meters from one wave crest to another wave crest or trough to trough, so this is lambda, or from here to here. All we are looking for is one complete cycle, and the frequency is the number of full cycles passing through a particular point per second. So that's in hertz. You should note that amplitude is basically how big the amount of energy is, how big the displacement is. So, for example, now I'm talking louder, the amplitude of the sound waves are greater, while now, when I'm speaking softer, the amplitude is smaller. Wavelength affects the type of wave. It's the quality of the wave. So, for example, if I speak in a higher pitch, when I speak of a higher frequency, when I speak with a lower pitch, the frequency is lower. With light, different wavelengths correspond to different colors. The speed of a wave is determined by the following equation. Speed is equal to the wavelength times the frequency. It gives me the speed. And for light waves in vacuum, this is 3.00 times 10 to the 8 meters per second, where the wavelength is measured in meters and the frequency is measured in hertz, which is equal to inverse seconds. So let's take an example. Calculate the frequency of the UV light with a wavelength of 300 nanometers to three significant figures. So, first I want to know the wavelength in meters. So I convert 300 nanometers. I divide by 10 to the 9 nanometers per meter. Remembering that nano is 10 to the minus 9. And so that's 3.00 times 10 to the minus 7 meters. Therefore, the wavelength is the speed of the light divided by the frequency. So it is 3.00 times 10 to the 8 meters per second divided by 3.00 times 10 to the minus 7 meters, because that's my wavelength. and I get a frequency of 1.00 times 10 to the 15 hertz.